Hey everyone, today we're going to be solving exponential equations. This is really similar to what we did on Friday when we were solving logarithmic. It's just exponential. So those are the 4 steps there at the top. You're always going to want to rewrite the equation using a common base. So you could see from the examples already, they both have 3 as their base, they both have 5 as their base. That's what you want to see every single time. Step 2 is you're going to use the properties of exponents to simplify each side of the equation. So the properties of exponents are really similar to properties of logarithms. So product rule means that you're going to add. Quotient rule means that you're going to subtract, and so on. Step 3 is you're going to use the one-to-one property of exponents. So the same thing as logarithms. If you have two exponents with the same base equal to each other, then their exponents are also equal to each other. And then you're going to solve the resulting equation. So let's look at the first example. We have 3 to the 2x minus 9 power is equal to 3 to the 7th power. So if you remember the steps from above, you always want to make sure that they have the same base, which they both have 3 as their base. So step 1 is already done for us. Step 2 is you want to simplify each side of the equal sign. But right now, I only have one term on each side. So again, that's kind of already done for us. Step 3 is to use the one-to-one property. So since they are equal to each other and they have the same base, we could just completely ignore that big number and only look at the exponents. So I can think of it as 2x minus 9 is equal to 7. Then from here, it's a two-step linear equation. We're going to add 9 to both sides, which gives me 2x equals 16. Then we'll divide by 2, so x equals 8. Okay, let's look at our next example. So now I have 5 to the c minus 1 power times 5 to the 3c plus 2 power equals 5 to the 7c plus 16 power. So they all have the same base, which is 5, so that's good. But on the left side, this is step 2, we want to simplify using the properties of exponents. So that dot right there means that they're multiplying, and the product property says that when you're multiplying two things with the same base, all you have to do is add their exponents. So I'm going to have 5, but now let's do our addition. C plus 3c would be 4c. And then negative 1 plus 2 would be positive 1. So that becomes 5 to the 4c plus 1 power equals 5 to the 7c plus 16. That one didn't change. But now that they're the same base, I can use the one-to-one property and only look at their exponent. So 4c plus 1 is equal to 7c plus 16. Okay, so let's get our c's to the same side, so minus 7c from both sides. But while we're at it, let's get the constants to the right. So I'm going to minus 1 from both sides. So here on the left, I'm left with negative 3c, while this cancels out, is equal to, this cancels out, and then I have 15. Divide by negative 3, and we get that c is equal to negative 5. Okay, now my third example. 8 to the m squared plus m power times 8 to the 2m minus 9 power is equal to 8 to the 4m power times 8 to the 11th power. So again, you want everything to have the same base. That's step 1. So right now, they all have 8 as their base. That's good. Step 2 says that we need to use properties of exponents to simplify. So here on the left, we're going to be able to combine by adding the exponents. And then on the right, same thing. We're going to add those exponents. So this would become 8 to the m squared plus 3m minus 9 power. So you see that was the only m squared, but this m and this m combined to make 3, and that was the only constant. Then on the right side, I will have 8 to the 4m plus 11. Okay, now I can employ the one-to-one property and set the exponents equal to each other. So m squared plus 3m minus 9 is equal to 4m plus 11. So I'm sure you can see it already, but this one has a squared term. So that means that this is going to be a quadratic equation. So we want to set it up to where it equals 0. So this term here, I'm going to subtract it from both sides, and then this term I'm going to subtract from both sides. So minus 4m, and then just match it up with its like term. Minus 11, minus 11. So it'll cancel here, and it leaves me with m squared minus m minus 20 is equal to 0. Okay, so I need more space. I'm going to rewrite this over here to the side. Now I want to factor this. So I want two sets of parentheses, and we are using the variable m. Think of two numbers that when you multiply them will give you 20, but when you subtract them will give you -1, because that's what's in the middle. So for us, that's going to be +4 and -5. Now all we have to do is set each one equal to 0. So m plus 4 equals 0, which means that m would be -4. M minus 5 equals 0, which means that m would equal +5. So you may have noticed for these top 3 examples, every single one already had the same base. So 3 is equal to 3, 5 is equal to 5, 8 were all the same. What do we do when they don't have the same base? So my next 3 examples are going to cover what we do when that happens. Okay, so let's look at example number 4. 9 to the 4y minus 14 power is equal to 81. So what you need to try to do is see if you can make them have the same base. So right now, 9 is a base here, 81 is a base here. Is there any way that I could make them have the same base? Well, yes, there is. So I'm going to write this off to the side. 81 is a perfect square. It's just the same thing as 9 to the second power. So if I write it that way, then they'll have the same base. So I could rewrite this as 9 to the 4y minus 14 power is equal to 9 to the second power. Now that they have the same base, I can use the one-to-one property and only look at the exponents. 4y minus 14 is equal to 2. This is just a two-step linear equation. Let's add our 14 to both sides. 4y equals 16, then divide by 4. Y is equal to 4. So that's what you're going to look to do if they don't already have the same base. Look to see if they're multiples of each other. That way you can make them have the same base. Okay, let's look at our next one. 2 to the n minus 9 power is equal to 32 to the n plus 3 power. So 2 is already as small as it can get, so I know that one's not really going to change. But let's see if we can write 32 as a power of 2. So again, I'm going to kind of write this to the side. 2 to the first power is just 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. There we have it. That's the one that we need. So instead of writing 32, I'm going to write 2 to the fifth power. but it already has an exponent, so we're going to have to add that on to the end. So here's how we're going to write it. Left side is going to stay the same, 2 to the n minus 9. Then on the right, 32 is 2 to the 5th, but then the exponent that it already has still needs to be there. Okay, again, left side's going to stay the same, but on the right side, let's distribute that 5, so it would be 5n plus 15. Okay, now I can employ the one-to-one property and only look at the exponent. So n minus 9 is equal to 5n plus 15. Let's move our n's to the left side, so I'm going to minus 5n, minus 5n. But then let's move the constants to the right. So I'm going to add 9 and add 9. So what that leaves us with is negative 4n, these cancel, is equal to, those cancel, 24. Now let's divide by our negative 4, and n equals negative 6. Okay, and then one last example for you guys. Number 6. 1 over 12 raised up to the 4x plus 3 power times 12 to the x squared power is equal 12 to the 2x plus 13 power. Okay, so this one has a 12, this one has a 12, but then this one is 1 over 12. So I need to fix that to where it's just a regular 12. So since it's still the right number, it's still 12, it's just in the denominator. So you can rewrite that as 12 to the negative 1 power. But then it already had a power, so that still needs to be there. And the rest of the equation is going to stay the same. So let's just rewrite that. Okay, now on the left side, I have two terms. I want to put them together. So whenever, this is a product property, whenever you're multiplying, all you have to do is add their exponents. So actually, I think I forgot a step. That negative 1, we need to distribute it. So that's negative 4x minus 3. Now let's add those exponents. So this would be 12 to the x squared minus 4x minus 3 power is equal to 12 to the 2x plus 13 power. So now they have the same base. One-to-one property says that I only need to look at the exponent. So x squared minus 4x minus 3 is equal to 2x plus 13. It's another quadratic equation because of that x squared term. So we're going to get both of these terms and move them over. That way it can be equal to 0. So minus 2x, and then just line it up with the like term, minus 13. So everything's going to cancel on the right, but on the left we'll have x squared minus 6x minus 16 is equal to 0. So I'm going to rewrite that equation over to the side because I'm running out of space. Okay, so again, I need to factor this. They are using x's. So I need two numbers that multiply to 16, but when you add them up, give you 6. Or they're both negative. So one's going to be negative, one's going to be positive. So there's 1 times 16, that's not going to work. 4 times 4, not going to work. 2 times 8, that's going to be the one we need. So positive 2 and negative 8. And now set each one equal to 0. So here we have x is equal to negative 2. And x is equal to positive 8. Okay, so for these last three, when they don't have the same base, you're going to have to make them have the same base. So you're going to have to look at your exponents and your powers of numbers. So for now, I left them fairly basic, like they're pretty much easy to see. This one was the hardest one, but as long as you go down the list, it's pretty simple. And for the most part, once you get them to have the same base, all you're going to do is look at the exponents from that point forward. Okay, guys, so you do have a short assignment for today. It's going to have these kinds of equations on it, exponential, and it's going to have some from Friday. So please look at your notes from Friday and for today and let me know if you have any questions. Bye, guys. Have a good day.